4.4, evaluating logarithms and the change of base theorem. All right. So, first problem say to find each value, if applicable, give an approximation to 4 decimal places. So 12, we have log of 10 raised to the 7th. So this one doesn't have a base written, but we know that that means it's base what? 10. So there's a lovely property that I don't know if y'all actually have yet. Maybe you do. I don't know. That basically says if the base and this number are the same, then the answer is whatever is up here in the exponent. Because with the power rule that we had last time, we could rewrite this as 7 log of 10, and that would just be 1, so this is equal to 7. All right, 14 log of 0.01. So this one is also base 10. So we can think about this a couple ways. We can set it equal to x because we're trying to figure out what this whole thing is equal to. And we have a log, so we can use our e to solve it and do 10 to the x is equal to 0.01, and then we can think about how to rewrite that so that those are equal. But you probably, well, you may or may not know that right off the top of your head. So if you get out your calculator, I'm going to show you how to just type it into your calculator instead to solve it. All right, so on the left-hand side of your calculator, there is a button that actually says log on it. It's kind of hard to see, but it's over here. It just says log. That is for a common log, meaning log base 10. Any of the other bases other than base E will have to do something different. But you'll just hit that button. Helps you turn the calculator on first. So then log and then 0.01. And that's equal to -2. Let's see, next one. 20 log of 296 times 12. So when we put this one in, to do log and then 296 times 12, like that. And that's 3.55. Let's see, 22 log of 643 over 287. So this one will basically be the same thing, just be with division in it instead. So log 643 not that much, divided by 287. So that is going to be 0.35. All right, one more of this type, and then we'll move into something a little different. Or we'll move away from common logs, I guess I should say. 26 log of 643 minus the log of 287. What do you notice about this problem compared to the last one?
Yeah.
Why?
Because you can only have one log, right?
Well,
or like one.
Yes. Like if we were condensing, like
Yeah.
you don't, yeah.
287 to 643.
Yeah. So if we use the properties that we had, right, we would do this one minus this one would be 643 over 287, which is up there. But if you want to see that that property is true, you can type it in 643 minus, and make sure you use parentheses or it'll think it's all inside. And it's the exact same thing. Okay, let's see what's next. All right, now we're going to do the same thing, but with the natural log. So natural log is log base E. On your calculator, it's the button over here that says ln. This is so blurry. But it's the ln button over here, so that's the other option. So 46, we have the ln of e to the 5.8. So this problem is just like the first one that we did today, where we had log of 10 raised to the 7th, okay? That one was a common log, so it was base 10, and it was of 10, so we said it's equal to the power. This one works the same way. This is base e of e, so this is going to be equal to 5.8. Let's see. 52. ln of 39. So now on your calculator, you're going to use the ln button instead. So it'll be ln and then 39. And that's 3.66. Let's see, 54. ln of 0.0077. Same thing. And this one ends up being negative 4.87 when it's rounded. Any questions about those or typing them in? So there's in that section of the natural logs with the ones that have the ln, there's problems like all of these type I did up here. So you just use a different button on your calculator to solve them, because those are not obviously things that you would know because they're coming out to be decimals. So the reason I did like 46 and 12 without the calculator is because that's just a property of logs that I know without having to type it in. But if you needed to type it in or you weren't sure if you did it right, if you type it in, you'll get the same thing that we wrote. All right, jumping to change of base theorem. If they don't specify what base you're changing it to, it's assumed to be a common log. Okay, it's assumed to be log base 10 that you're changing it to. So 80 log base 2 of 9. So a lot of people, their temptation is just to type this in the calculator using the log base option, but we can't do that. We have to use a change of base formula. So the change of base formula that you have in your notes is that whatever the number is here is getting written in the top, and then whatever the base is going on the bottom. So this is going to become log of 9 over log of 2. And then it does want us to give a final answer. So we would type these in. Again, make sure you're careful with parentheses. So we would do log of 9, make sure you close it, divided by log of 2. And that'll end up being 3.17 for that. Um, 84 log base 1/3 of 2. So how would I write this one? I need to rewrite it as a change of base formula.
Log of 2 over log of 1/3.
Yep, log of 2 over the log of 1/3. So then log 2 divided by log 1/3. So that's negative 0.63. Let's see. One more. 86 log base pi of the square root of 2. So how am I going to write this one?
Log, whatever that is, 2.
Square root of 2.
Over. Just put pi, or would you put 3.1? Like the whole thing.
I would use pi because you're going to use the button on your calculator.
There's a pi button.
Yeah. It's above the little caret button over here. Right there. So at a minimum, even if you, like, let's say you didn't know there was a pi button and you just use 3.14, still write pi here, because that at least shows me you know that you're setting it up. And I mean, using 3.14 should get you pretty close to whatever it ends up being. So log of, and the square root is above the little x squared over here. So you have to do second, and then that button, 2, close the parentheses, divided by log of second, and then you hit the little caret button, there's the pi. And so that ends up being 0.30. All right, any questions on that? Anything? Pretty easy section overall, I think. You basically have your calculator for everything except for the setup of change of base. All right, so problems then. 11, 15, 19, 25, 45, 53, 59, 81, and 89. So you should have time to finish it because we still have like 25 minutes left. And then if you haven't already done the notes for tomorrow, you need to go ahead and do those for 4.5.